Hi everyone, my name is Xiaowei Yao. Let me introduce you my program. This is a little game called Frozen Lake. I use it to create the game. This game is in this game you need to control a little man and and help it to avoid the traps and finally get a gift finally get a gift. And this I used the GYN library and you incorporate with the Pygame to achieve it. This is the environment. So uh, in this video, I will change it. I will change the map size to the 4 because why? Because the A to A is relatively large and it is very time consuming in the training step. So I change it to the 4 can help you to see this result directly, to see this result more easily, and and also it is useful for showing. And also, this is the function I create for this program, and which will be shown in the following part. And let's go to this part. The Let me introduce the main parameter. This is the total number of the training episode. In this time, because we go into the 4 map, so I can reduce the training episode. And also, because the reduced number of the training episode, total training episode, the learning rate should be a little bit higher than before. Because in the larger model, the model in a larger map, the model need to learn slowly. So I increase the learning rate into the A to A. And also the evaluate episode in total, I also set to the 100. Okay, another thing is that the gamma and the max step or the max step is very important. I use this to limit it the little man in only can walk 90 lower than 99 step in every episode, because the little man cannot run endless in single step. That is very ridiculous. Yes. And then I used the max epsilon and the min epsilon to control the range of the epsilon, which is a value used in the epsilon greedy policy. And also the decay rate should be a little bit higher. I will set it to the 0 higher because it is a lower function, lower map, so it should be higher in the decay rate. The decay rate is help you to control the little man's behavior. This is mainly cooperate with the epsilon to control the epsilon. Oh, that's too early. So let me introduce the main step. At first, where I use the OS library to make sure to check wherever there is an existing Q table in our map or in our file. If it has, I will directly load it and use this Q table to train the model. And if it doesn't, I will use the initialize Q table to create an empty Q table at first, and use this Q table to save the training data in the training from the training step. And then we go to the training step. After training, we save it by this save Q table. Finally, we use the evaluate agent to evaluate the result of our trainings of our Q table and print the min reward and the STD reward to show our model is bad or good. So this is the main step. Let's begin to see how it works. So you can see at the first time the little man go randomly because in the training step. now we use the TQDN library to make the training process more directly to see, more easy to see. Now it's just going to the 8%, and let's see at first. So this is a 16 and the 4 is the little man's behavior and the space it can go. It only can go to the 16th place. 1, 2, 3, 4, 1, 2, 3, 4. Yes, and the it only can have four behavior: up, down, left, and right. And so let's see the functions. The initialize queue table is used to create the empty queue table. Use the NumPy library. And then in order to achieve the queue table method, I create a greedy policy. This policy is used to choose the highest queue value, highest queue value into the highest queue value related action and state, and then it will return the action. And also I use it into the epsilon greedy policy. This time I use the random number to create a random num and compare it with the random number epsilon. The epsilon is also if the random number higher than the epsilon, it will do the actions, the best actions based on the queue table shown. But if it doesn't, it will like this. It will do the random behavior. The little man when he in the map. So let's go to the training function. At first, you can see the epsilon is relatively higher at first, because in this time it has the higher probability to go to the random behavior, run everywhere, run every time, run every place. To just need to so it has the higher choice and higher result and the more diverse result to storage into the queue table. Oh, by the way, the queue table will be saved into the file like I named, and the saved queue table will be set into here. Yes, this place. Use this function. Use this method and this method to load and save. And also the way is storage saved into the queue table is overwrite, because overwrite, not instead of appending. Yes, that's it. Okay, let's get back to the training process. And then after with the increasing of the training step, it will the epsilon will be lower. So if the random number is higher than the epsilon, it will choose the best way. Choose the best way that it ran before. So it will always choose the best way to get to the gift and in the shortest. And also because on the other hand, it will get a new state, reward to every step in every episode. It will get a new state, reward, terminate or truncate in every step. So the new state, the reward, if the terminate or trunc becomes true, it means that the little man go into the trap or get a gift. This episode will end. This step will end and go into another episode. And then if we get to the gift, you get it get 100 point. If we go into the if the little man go into the trap, the reward it will get 10 negative point. And also every step he runs in every episode, it will get the 0.1 negative point, which help him to go to the best way in the short way. And also you can see this. Now we are into the evaluate function. As you can see, after the training, the little man will always choose the best way to get a gift. It can avoid the trap and go to the gift in the shortest way. It is very it is very useful, and it is very useful, which means that our model is very It's great. And then after the step, it will and then after to calculate the reward, it will update the Q table. As you can see, the update the Q table I learned from the website is like this. This is the formula, and I achieve it in this, by this code. And then after whatever it terminates, chunked, or nothing happened, it will always update the state to the new state and return the Q table. So after it returns, it will go to another episode, and another episode finish, and then you save it to get the Q table frozen lake PKL, and then we go to the evaluate agent. Evaluate agent is the same as the training process. It's just shown like this time. It will always training the best place, because it will because in this place the little man will follow the greedy policy, always choose the best way to go to, best way they can get the action that can get highest value to finish this game. And nothing it is very but what's new? It will the new thing is that the reward will be recorded into the total rewards EP, like this. Because in every loop, the total reward will be added in there, and then finally the mean reward, and then our program will calculate it and get the mean reward and the STD reward, and then finally it will print it. Okay, now finally let's check the load Q table. If you have, as you can see, we use the save Q table to get a Q table frozen lake PKL. So if we want to use it now, you can. If we want to use it now, it will go. If we want to load it, it will go into this place. So as you can see, the file is in this file is in here. So if we want to run it again, it will be showing like this. Yes, exist. So when you're training, it will exist, and training it like this. Okay, that's all my video. Thank you for watching.